Today, folks, we are going to learn how to divide polynomials using a method called synthetic division. Now, your know and do is before you, so please write it down in your Cornell notes. Our Wicker know and do is the word synthetic. What is synthetic? Now, here's what I'm going to try to link to. If somebody says synthetic, usually that means not real. Well, guys, that's kind of like what the synthetic division is. It's a shortcut for dividing polynomials that only works under certain situations. It's kind of like synthetic leather. If you were to buy a cell phone and get a leather case, the leather case would be more expensive than the synthetic leather case. And the synthetic leather case won't last forever, or as long as the leather case will. Likewise, synthetic division only works under certain situations. All right, well, let's go ahead and begin our instructional material for today. Today we are going to start by reviewing long division, and we're going to make a connection between long division and synthetic division. Now, let's just review. If we were to take the divisor x plus 2 and divide it into 2x squared plus a 7x plus a 9. Now remember, we're going to ask ourselves, what times x gives me 2x squared? And that, of course, is 2x. We put the 2x right there. Then we take 2x times x gives us 2x squared. And remember, it gives us the same thing as what you saw right here. If it doesn't, we've done something wrong. And then we're going to take 2x times 2, and that gives us plus 4x. Then we're going to change the signs and add. This subtracts out. Here you get a 3x, bring down this 9. Then we ask ourselves, what times x gives us 3x? Well, that would be plus 3. 3 times x is 3x. 3 times 2 is 6. Okay, then again we're going to change the signs and add. This subtracts out like it always has to, and you're left with this 3, and that's a remainder which we're going to put x plus 3 over top of x plus 2. Okay, and there's our answer. All right, now let me show you another way called synthetic division that makes this process quicker and I think easier as well. On the left side of your Cornell notes, I want you to write the word synthetic division, okay? And then I want you to put this definition down. It is a shorthand method of dividing a polynomial by a linear binomial by only using the coefficients. Now, this word right here is very important. It has to be a linear binomial. For example, look at this one here, x plus 2. That is a linear because it's x to the first power, and it's a binomial because it has two terms. You can only use synthetic division when your divisor is a linear binomial. Okay. All right, go ahead and pause. Make sure you get the rest of this definition down, and then we'll go on and learn the method. Okay. Let me step you through the process. Now, first of all, what we're going to do is we're going to take this x plus 2, that divisor. We're going to set it equal to 0, and we're going to solve for x. Now, to solve for x, I'm going to subtract 2 to both sides, and you're going to get x is equal to a negative 2. Now, I'm going to take that negative 2, and I'm going to put it right here. Now, notice here I have my dividend. My dividend is already in standard form. Now, I'm not going to put the x squareds or the x in there. I'm just going to take each of the coefficients of each of the terms, and I'm going to put it here, here, and here. Now, here's what's going to happen. We're going to take this 2, and I'm going to drop it down. Then I'm going to multiply this negative 2 times this positive 2. That gives us negative 4, and I'm going to put it right underneath the 7. Then we're simply going to add. We do not have to change the sign here. Now, in your Cornell notes, I want you to make a little note on the left side. And that little note is going to say You do not have to change the sign of that. Okay? All right, so now we're down to a 3 here. Now I'm going to multiply negative 2 times 3. That's going to give me 6, and I'm going to put it right there. Okay? All right, now I'm going to add again. 9 minus 6, and that gives me a positive 3. And then I want you to notice we get the same thing that we got on the previous page. Now, here's something that I want you to notice here. When you're writing this out, something that I want you to be careful of here. Okay, up here we had x to the second. It's going to drop down 1 degree. So when you put the variables back in for the 2, you're going to drop it down 1 degree. So it was x squared up here. It becomes x, then just the constant, and then just the remainder over the divisor. All right, let's go try another. Okay, for this problem, first of all, we need to make sure of a few things. First of all, is this a linear binomial? If it is, then I can use synthetic division. If it isn't, that means I have to use long division. Secondly, look over here. Is it in standard form? Yes, it is. Okay, so the first thing we're going to do is I'm going to take that linear binomial and I'm going to set it equal to 0 and solve. So we're going to add a 1 to both sides, and I get x is equal to 1. That's the number that's going to go out front. So I'm going to take that number and I'm going to put it right there. Okay. Next, look here. Yep, it's in standard form, so I'm going to take that 3, 9, and then negative 2. Make sure you take the negative signs with each coefficient. I'm going to put the 3, 9, and negative 2. Now I've set the problem all up, ready to use the synthetic division process. Okay, so let's go do that. First thing I need to do is we're going to take this 3 and I'm going to drop it down. Okay, so let's put that 3 right there. Then I'm going to take 1 times 3. Put a little times there, and that's 3. I'm going to put it right there. Now, next, I'm just going to add down. Remember, you don't have to change the sign. 9 plus 3 is 12. Now I'm going to multiply again 1 times 12. So I'm going to multiply that again. That gives me 12. Then I'm going to add down. Okay, let me show that here. We're going to add down, and that gives me a 10. Okay, now let's write it as the quotient to the problem. Remember, we need to step down 1 degree. For example, this is what I'm talking about. Remember, in the previous problem, it was 3x squared plus 9x minus 2y. Well, that means I'm going to step down 1 degree. So I'm going to take this 3, and it's going to be 3x plus 12 plus 10 over the divisor. Okay? So that means it's going to be 3x plus a 12 plus 10 over top of x minus 1. And there's our quotient. All right, folks, in taking a look at this problem, let's see here. Well, the first thing that we need to do is we have x plus 2. We need to find that a value. So we set it equal to 0, subtract 2 to both sides, and you get x is equal to negative 2. So negative 2 is our a value. All right, now let's look here to see if we're missing anything here. Wow, look at that. X to the third, x to the first. So I need to slip in here, right in here, and I need a plus 0x to the second. All right, so in putting that in place, we're going to put a 3 right there, then a negative 1, then a 0, then a 5, and then a negative 1. All right, so now let's put that negative 2 right here. Take the 3, drop it down. Negative 2 times 3 is negative 6. Now negative 1 minus 6, is going to be negative 7. Okay, negative 2 times negative 7 is 14. Carry that down. Negative 2 times 14 is negative 28. Now, negative 5 plus a negative 28 is going to be a negative 23. And negative 2 times negative 23 will be a positive 46, which will give us a 45. All right, now, that's our remainder. So, now let's go ahead and write our quotient. Couple ways you could do this. You could go backwards or forward with it. Okay, I'm going to go the forward way with it. So let's see. Looking up here, I see this is 3x to the 4th. So I'm going to drop down 1 degree. So it's going to be 3x to the 3rd minus 7x to the 2nd plus 14x minus 23, and then it's going to be plus the remainder, so it's going to be 45 over top of the divisor, which is x plus 2. And there we go. That is your quotient plus the remainder. Now, how can I use synthetic division? Well, there's a process called synthetic substitution, and we're going to use synthetic substitution to evaluate a value for p of 3. Okay, so here's what we're going to do. We're going to learn a theorem. So on the left side of your notes, put the word remainder theorem, and on the right side, I want you to write this theorem and also this example right here. Okay, so if I take x minus 3, I take 3, we're going to use synthetic division. Now, you can look to see how this goes through, but I want you to realize the remainder is 7. Now, here's what I want you to see. Now, I want you to notice something. If we were to take p of 3, and I were to plug in 3 cubed minus 4 times 3 squared plus, and I'm kind of running out of the room, so I'm going to wrap it around here, 5 times 3 plus 1. Now, here's what I want you to do. Take your calculator, or just do it manually, and I want you to evaluate this. Okay, so go ahead and pause it here, and tell me what p of 3 equals. Okay, go ahead and pause it and do that. Okay, now that you've done that, what did you get? Did you get 7? I did. Now, is that a coincidence? Is this remainder always the same as just plugging it in? It isn't. That's what the remainder theorem is all about. So, from now on, instead of substituting it in like we did right here, we can use synthetic substitution to evaluate a function for a value. Okay, folks, let's try another one. Let's make sure it wasn't just coincidence that this worked. Okay, so here's what we're going to do. First thing we're going to do is make sure this is in descending order, and we have x equals 2. Now, notice here I did not have to solve it because it's already x equals 2. So there's my a value. So we're going to put that a value right there. And let's put each of these coefficients right there, right there. Okay, now, first thing I do is I drop down that 2. Then I went 2 times 2, and I get 4, and I put that 4 right here. Okay? Next thing I'm going to do is add 5 plus 4, and that gives me, you said it, 9. Then we're going to take that 2 times 9, and that gives me 18. Add the negative 1 plus 18 together, gives me 17. Then I take 2 times 17, that gives me 34. Then I add 7 and 34 together, gives me 41. That tells me that my remainder is 41. So, if I take this 2, and I were to plug that 2 in for x in these 3 areas and evaluate it, just like what I showed here, what should I get? Should I get 41 like what showed up right there? Well, you try it and see. Okay, so go ahead and pause it, evaluate that, and tell me if you get 41. Okay, now that you've done it, did you get 41? I sure did. Okay, let's move on. In this slide, let's do an example of where this synthetic division is going to be used. Okay, and it says, let's read this together. Write an expression that represents the area of the top face of a rectangular prism when the height is x plus 2 and the volume of the prism is x cubed minus x squared minus 6x. Okay, so let's draw a picture of what we have here. I have a rectangular prism. So it's going to look something like this. Okay, now we know that the volume of this is going to be x cubed minus x squared minus 6x. Okay, now I know that the height of it right here is x plus 2. Now what I'd like to know is I want to know what the area of the top face is. In other words, what's the top area of this top face right there? Well, first of all, let's ask ourselves, is this right here a linear binomial? And if your answer is yes, let's take it and let's set it equal to 0 and let's find our a value. So we're going to subtract 2 to both sides. Gives me x is equal to a negative 2. All right, now take a look at this volume here. If we look at that volume, is it in descending order? And yes, it sure is. Okay, so let's take that and set it up in our synthetic division. So it's going to be negative 2 right there. We're going to go 1, negative 1, negative 6. Now, I'm going to put a placeholder for the constant there. Okay, because down below that is my remainder. Okay, so now let's step through this. Okay, so I drop down the 1. Negative 2 times 1 is negative 2. Now we're going to add down negative 1 plus negative 2 is negative 3. Now I'm going to multiply. Negative 2 times negative 3 is 6, and that gives us 0. Okay, then negative 2 times 0 is 0, and 0 plus 0 is 0. So since 0 is the remainder, that tells us that it goes in evenly. All right, now remember, I need to step down 1 degree. It's x cubed. So when I rewrite this quotient, it's going to be 1 x squared minus 3x, and I don't need to put the plus 0. Could if you want, but I wouldn't because 0 plus anything is just that same anything. Okay, so what does that tell us? Well, this tells us that the top face is going to have an area of this polynomial right here. So make sure you write your answer as a sentence. You're going to say the top face has an area of x squared minus 3x. Now, let's look to see if it has a unit. Looking at the problem, I don't see a unit. So, you're just going to say x squared minus 3x, and then I'm just going to say units squared. Period. And there you go. Okay, folks, well, that's going to wrap it up for today. Now you've learned synthetic division. Tomorrow when you come to class, we're going to be taking a look at these questions right here and practicing them. Now, you're going to notice that number 12 is misplaced. No, it's not. The reason why that number 12 is in the middle is because I want you to do these problems before doing this application problem. Okay, so when you work it out, make sure you keep those in order just like how I put them right here. All right, folks, well, that's a wrap. I will see you in class.